Hi, so I'm just going to be going over using this tiling program I wrote for Klayout in a quick video in addition to the documentation I wrote here on my GitHub. So the steps to running this program are first, you should obviously clone the repository and download it. It should run on anything where Klayout can be installed, so it doesn't matter if it's Windows or Mac or Linux. And so once you have the repo downloaded, you're going to want to go ahead and open up Klayout and just add the macro that I made. So you go up here to macro development, and then you add location. So the location you're adding is wherever you downloaded your macro. So in my case, it's right here. And then here's where it appears in the development tab, but it should appear here as well. You can see here it's this library of 40 cells with varying transistors here being tested. And one thing you'll notice about all these cells is that they all have the same vertical and horizontal pitch. So if you're measuring them across and from top to bottom, these are all going to be the same size. That's important when you're going to tile them. Otherwise, the structure is going to get very unorganized. So assuming that you already have this macro downloaded and loaded in, it's just as easy as this. So here's what the GUI looks like. And let me go ahead and run through some of these parameters. So in terms of the general subcell parameters, this is the only thing you absolutely need to run the program, and that is the pitch of your subcells and the gap that you want in between the tiles that you're doing. So in this case, if we measure the horizontal pitch, you can see it's 280. And that's what we have here. That's just the default that I have. And then the Y pitch is going to be 68 microns. Same way. So this is all in microns. And when it says width here, that's just referring to how many subcells they're going to be across. So there are 40 tiles here, 40 parts of the library, and they're going to be placed 5 across. So we're going to have to select the output directory where we want to place these. So I'll place them right in the example directory, and then the tiling cell file, that's what we're working with right here. So you can run this program, this macro, outside of any active layout. It just kind of runs by itself. So you just need to reference this file right here, 1T1R library example. Okay, so now going on to the markers. These are optional, but obviously probably going to be used in a given situation. So there are some little things to note with the markers. So, and this is the marker example file that I give. So there's one file, and it has three different types of alignment markers. The alignment markers can be anything you want, but the origin, these all have to be placed at 0, 0, meaning if you look at the cell like this point always has to be 0, 0 across all three. A good way to check that, I found, is to use a box measure. Just take this here and here, and then if you look here, this is the lower left point, is these two. So we can see that this is placed at the correct spot. So for this example, let's use cross 2, which looks like this, and it's also placed in the correct spot. So let's go back to our program here. Okay, so, and we're going to name it demo layout. Okay, so we're going to place markers. Let's place well, yeah, let's place 4. And so we're going to reference this file right here, but we're not using cross1, we're going to use cross2. So the placement origin, this may seem a little bit confusing at first, but basically when these cells are generated, it's just going to place the markers in a horizontal row in a gap, and it may seem counterintuitive to do it like that, but it'll be clear in a second why you don't need to place them, give exact placement coordinates for each individual marker. So this is just so you can place them in a place where they're out of the way. So down here you can see the coordinates as I move across the layout. So maybe a good spot to place these would be right about here, which is about 162. So 162, and the gap in between them is just what it says. This is not super important, but 10 is big enough for this particular alignment marker. Okay, so now moving on to the text, as it says here, this is the this part is kind of a little bit hard coded to a naming convention for these particular devices. So by default, it's assuming that you're placing some sort of transistor with some sort of width, length, and voltage, and that's following this naming convention. So this is helpful if you're doing the same thing, but obviously if you want to place all these cells and you're placing something different, it's some sort of different device, and it has a different width and length or a different parameter for each tile, and you want to place the name according to whichever cell it is. You have to edit this function as it appears in the source code for the macro. So it basically just works off of the naming conventions for the cells. So we can actually just take a look at it right here. So here's the actual code. And if we go all the way down here, so this is where, if we go all the way down here, if we go all the way down here, this is where the width, length, type, voltage, this is where all the parameters are supplied, and this is where the text is formed. So you can see right here, here, this is what's going to appear on the output layout, and this label, the prefix, is what is being asked about here. So in this case, you can just make it demo, and we will place test. The layer number is self-explanatory, font size, and this is also kind of self-explanatory. So the placement origin, this is also kind of important. It's the same deal as the markers. What we want to do in this case is place the text so that it's flush with this green like outline of the cell. So we can get out our measuring box and make sure this is flush. Okay. And once again, we're looking for the lower, well, we're looking for this point right here. So that's going to be 068.01, these two coordinates. So we can go back. Oops, sorry. Go back. 068.01. Okay, so that's everything we need, and now we're just going to generate our output. Okay, so we have a layout generated successfully, and now we can go open it up and look at, see what we have. So here's my here's the demo layout. Right, so this is exactly what we're looking for. These are placed, they're 40 across, there's 5 transistors, and if we look at the text here, it's just demo, and then these are all the parameters that were extracted from the subcell's name. So, and it has it set up in a nice way with like a hierarchies, so that, and that's important for these markers. So for the markers, you can see they're present. The markers and text are all present as subcells of each individual device tile. And the nice thing about these are that if I take this one here and move it like in here, so if I were to take these and center them and put them exactly where I want for this tile, and I go to the top, these all move in sequence together. So they all mirror each other. So you only have to adjust the markers one time for one of these cells to where you want them, and then you're done. So that's a quick overview of this program. Hopefully it can be useful, and if you have any other questions, there's some more detail in the documentation on the GitHub.